Okay, another time. Hello everyone. We are in part 11 of our tutorial. In this tutorial, we got to know how we can use our RTOS, OTP RTOS, OpenTeach project RTOS in STM32 Cube IDE. But for the last part of this tutorial, I want to say how you can use Semaphore system calls from interrupt, Semaphore get or Semaphore release. But Semaphore release is more important than Semaphore get. Semaphore get is not, it's not so important. Semaphore release is so important. I will say you why. But before talking about Semaphore system calls from interrupt, I should say there is another difference between Matrix and Semaphore. You can't call Matrix system calls from interrupt because Matrix needs owner, and owner is a thread. And you must call Matrix system calls from thread mode. Okay, you can't call that from interrupt. It's a logical reason, okay, not it's a practical reason. Okay, but I said I want to call Semaphore system calls from interrupt, so I need to have an interrupt in my project. I can use PI11 as an external interrupt resource on my board. This pin connected to blue push button on my board. I want to use blue push button as an external interrupt resource. To configure this pin as a external interrupt resource, you must do some configurations. For example, here check as an external interrupt. After that, in NVIC you must check this checkpoint to create code for this interrupt, and in GPIO set it as external interrupt with rising edge trigger detection. Okay, you must do these configurations to set this pin as an external interrupt resource. Okay, so after that, an important question: why Semaphore release, especially Semaphore release and get from interrupt is important? What is the application of this system calls from interrupt? This is an important question. Let's give you a scenario. Assume you want to use a microcontroller unit to control some things in a car, in an automobile, okay? And in this microcontroller, you want to use an RTOS, and you have 4 threads. Thread 1, check the heat of the engine, check and monitor the heat of your engine in your car. Thread 2, read and show the speed of the car, monitor the speed of the car. Okay, and thread 3, check how much fuel is left in your tank, monitor the fuel in your car. But there is thread 4 that is so important and so critical, controlling the brake in your car, ABS brake in your car. You know, thread 4 has higher priority, logically has higher priority, because braking in a car is so important process. Okay, so for example, give the thread normal priority and give the thread, for example, priority greater than normal, for example, high, above normal, high ISR, it's not important. Okay, a higher priority than others. So when you push brake on your car, immediately you want to run the thread. Assume when you push the brake, you have an interrupt. And by using of this interrupt, you want to immediately return thread 4 to ready list. By using of this interrupt, you want to immediately run thread 4 because brake controller in a car is a critical job. Brake controlling in a car is a critical job. Okay, how can I implement this project? By using a semaphore release from interrupt, you can do that. Let's describe that. In my project, I have two threads. Thread 1 has higher priority, it's a critical thread, and thread 2 has a normal priority. I have a semaphore. And the initial count is 0. It's so important. Initial count is 0. Now, in thread 1 with priority high, I want to control the brake. In this example, by pushing the blue button, because I pushed the brake, by pushing the blue button, we have an interrupt. And in this interrupt, I want to immediately run thread 1. Okay? You can see in this file, this STM32 fxx underscore interrupt.c. I've added include file RTOS.h in this file, and I've defined another time semaphore ID 1 here as an external variable. This is just like this is this variable. Okay, it's a global variable, and I want to use this variable here, semaphore ID. When I push the blue button, the operating system run this function. Okay, and in this function I want to release semaphore ID to return thread 1 to the ready list. But how? After starting the code, starting the RTOS run thread function 1. In thread function 1, this thread wants to get this semaphore, but the initial value is 0. Initial value is 0, so the operating system put thread 1 to the wait list, and each 100 milliseconds do this work. It wants to get this semaphore. Okay, but if I push the button, the operating system jump to this function, release the semaphore. By releasing this semaphore, immediately the operating system jump back here, because thread function 1 has higher priority, and toggle an LED on my board, a green LED on my board. Another time in while loop, go to the first of the while loop and get the semaphore. Another time, wait for release. Okay, another time, wait for release. In this way, you can implement a critical job in your project. So let's debug this code. So I'm in debug mode. Let's put a breakpoint here and put a breakpoint here and run the code. The operating system doesn't run this toggle LED, this critical work. But if I push the blue button, the operating system jump to this function, the processor jump to this function. Okay, let's do push the blue button. 3, 2, 1, push. Now processor is here and wants to release the semaphore. By releasing the semaphore, immediately jump to this block. Immediately jump to this block, toggle the LED, another time wait for semaphore, wait for interrupt. So let's do by pushing the blue button on my board, I can toggle the LED, immediately toggle the LED. Let's do show you the result on board. Open webcam, reset by this black button, and this is the LED trigger. If I push the blue button, sorry, there is a problem. Let's do it another time. Rebuild the project. Remove all of the breakpoints, reset and run the code. Okay, now let's show you the results. Now if I push the blue button, I can turn on and turn off the LED. Okay, push, push. Very good. Okay, this was an example how you can use semaphore release from interrupt, but you can use semaphore get from interrupt like semaphore release, but there is no difference. There is not a lot of thing to say. You can easily use that. Let's stop this project. Stop this project and show you here RTOS.h. Okay, here is RTOS.h. You can use semaphore get and semaphore release from interrupt, but when you use semaphore get from interrupt, the operating system doesn't care to timeout, because by using of timeout, the operating system wants to wait a thread, but you don't call semaphore get from thread, you call that from interrupt. Okay, so when you call semaphore get from interrupt, the operating system doesn't care to timeout, and you can put 0 in timeout. It's not important what value you put. Okay, and you can get a semaphore from interrupt. If the value of semaphore count was 0, the return value is error. If the value of semaphore count was greater than 0, the return value will be okay, status okay. Okay, so in this way you can use semaphore get and semaphore release. Semaphore release is so important. You see the importance of semaphore release in this example. You saw that. Okay, that was an introduction about RTOS, and that was a tutorial which shows you how you can use the OpenTeach project OTP RTOS in STM32 Cube IDE. But I will create more tutorial videos in future about this RTOS and about this project, and I will give you more information about my project in future tutorials. Okay, thank you very much to see me, and see you soon in the next tutorial, not next part.